If you guys are ready, I can read the first question.
Okay, I'm ready.
Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. So if I read the question right, I got 0.175.
That's what I got, yeah.
Same.
Okay.
Sounds about right to me.
Okay, I can read the next one. So, which of the following will have a smaller standard deviation? If 9 observations are randomly drawn from a population.
Would it be the second one? The distributions of the sample means?
I was trying to decide if you could be able to determine it.
Right, because it's one of those two. Each observation will stay the same no matter what.
Bless you. I guess it could be the second one.
So,
Yeah, or were there not
What do you
enough
guys-
tests? That's the big question, right?
Yeah.
I'm not really sure on this one, to be honest with you.
I don't know either, so
Should we, I mean, I don't know, whenever I've looked, I don't remember this being talked about, but
Yeah.
I just know in lesson 6 it talked about the more tests you perform, the smaller the deviation. But
True.
oh, that's right. That's right. The standard deviation, is that what you're talking about? Well,
Yeah.
no, that doesn't really.
Uh-huh.
And then in the videos, if you guys watch the videos, it went over chapter 5 and chapter 6. So this information is a review from that as well.
Probably.
True. So yeah, going with that thought pattern, the distribution of the sample means makes sense.
So you guys just want to go with that?
Sure.
True.
We're ready for the next question. I can read that. Which of the following results
Okay.
implies that the spread in X decreases as the sample size increases?
Is it the central limit theorem?
I know the
I
central
can't remember if it's that one
theorem
or the one under it.
says if a number is bigger, then it's going to always be normal distribution.
Yeah,
Right.
Yeah, that's true.
that imply that the spread in the random variable decreases as the sample size increases.
Would that fall under the law of large
Yeah.
numbers or the central limit theorem?
Doesn't that kind of imply that?
I feel like it works for both. But
Well, the law of large numbers was just accuracy is what the word that they kept on using to describe it.
oh,
And
okay.
so it was like in correlation. I don't know if that makes any sense.
Yeah, that makes sense.
So are we thinking the central limit theorem then?
Just off of the information that I can remember, that would be my guess, but I don't necessarily know that that's right.
I guess go with it because the other ones I don't think would imply that.
Slide part that's getting me. That's making me like, I don't know.
Yeah.
Right.
So I guess
But
the central limit theorem.
that was true in the last lesson that we studied from the central limit theorem, right?
Let me see if I can pull that stuff up.
Okay, well, you do that. Maybe we should read the next question.
That's totally fine. I'll try to pull up the definitions from those and we can go back over that.
Okay.
Do you guys want me to read the next one?
Yeah.
Sure.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places. Didn't we? Never mind. So I don't know if I did the right formula, but I got 1.045.
That's what I did. That's what I got.
I guess I'm close, but I didn't think I used the right formula.
I just used the z equals observation minus mean divided by standard deviation formula
That's
that
what
we
I
learned last week.
I forgot the subtraction portion. I think that's where my number came different than yours.
Okay.
I'm still trying to figure out this question, guys. This other question.
You're good, Abby.
I feel like it's like saying everything but that. So I'm just gonna keep on looking. Okay, so for the central limit theorem, it says the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. That's like the definition. But that doesn't necessarily talk about, I don't know.
One of us could put the law of large numbers because that's the only one that I think it could be if it's not central limit theorem. And
Yeah.
then there's like big
The
addition.
other two just doesn't make sense that it would be.
Yeah, because
Right.
So the central limit theorem states that if the sample size is large, that x, will be approximately normal.
So then
I
the
don't know.
law of
I feel
large
like-
numbers would.
And the law of large number states that as the sample size gets larger, the sample mean will get closer to the population mean.
Right.
Which that seems to be what this is saying, because you've got the sample mean is decreasing as the sample size is getting larger.
That makes more sense, kind of.
I think it's the law of large numbers.
I guess that
Okay.
I was getting standard deviation confused with the sample mean, with the central limit theorem.
Okay.
Yeah.
Okay.
So we'll try out the law of large numbers.
Yeah, we'll see what we get.
Yeah.
Okay. So number 6, how did you guys go about that one?
So take the score that the girl got minus the mean divided by the standard deviation.
So on number 7, we're gonna have to take the z-score we just got, right? And we're gonna have to put it in the probability applet somehow.
Yes. And then we only want above, so we'll have to click onto the right.
Okay.
Did you guys get 1.045 for number 6?
Yes.
Yes.
Okay, just wanted to double check.
So we just enter that number in the score spot, right?
Yes.
Yeah.
And then it gives us the answer of 0.296.
Click on the left blue
Or did I get it wrong?
goes away, so you only have the probability of the z-score and
Of
higher.
above. Okay. Which is the 148. 0.148.
Yeah.
Okay, so 0.148, we agree on that?
What?
So we agree on 0.148?
That's what I got, yeah.
That's what I got too. I wasn't sure if I did it right, so then when you said it, I was like, okay, that makes me feel a little bit better. Because I get a little bit confused on the shading part.
Yeah.
Yeah, that took me a minute to.
Yeah, so then I went through the video of the preparation work, and I saw him do it, and I was like, oh, that's how you do it. Okay.
Awesome.
So then on question 8, do you guys want me to read it?
Sure.
Sure.
Okay. So a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? So we're going to get the mean of those 5 numbers and then do the z-score based off of that somehow.
I think so, yeah. 50.
And so our mean of 150.8 and the standard deviation of 8.8 will still be used.
That's what I'm thinking, because it says use the following information for the next 4 questions.
The next 4, yeah, so whenever I got the mean of those 5 numbers, I got 160.
I did too. That's what has me confused because then it would be the same z-score as what we just saw.
Well, before they gave us a mean of 150.8.
So is it asking us to calculate the z-score for each one of those numbers?
And then add them together?
Well, it says, what is the z-score corresponding to the sample mean of these students' scores? So,
Full mean, and then we just enter that in, and then we get the z-score, right?
Yeah, so I think you're right. You find the mean of all the numbers and then put that into the formula.
Would this be totally off? I don't know if this is right or not, but what if we used 160 as our well, I guess that's what you're saying though, Emily, it would be the same z-score if we used it as the value again?
Yeah, we would get the same 1.045 if we use 160. That's why it has me confused.
I think it wants us to use that because that is the mean of the the sample.
Say what you said again, Jacob, because you're saying don't use a formula, just type it into the probability applet. Is that?
No, I'm trying to just figure it out myself. But then again, I guess the mean does mean the middle number, which would be, again, the 160. So.
Okay, so just looking ahead to see what our next question is going to be and if it affects this question. Question 9 says, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So to me, that makes it sound like the mean is supposed to be a different number, but maybe not. That's just what I'm guessing because it says in the previous problem. I don't know if that means in question 8 or if that means like from question 6 or whatever.
I think it's asking for from question 8. But then again, now if we use the same number as like 160 for 8, 7 and 9 will have the same answer.
Right.
Oh, so I think we do use 160, but for the bottom of the denominator, we put 8.8 divided by square root of 5 because we actually have a sample size now.
Oh, so that's, I get what you're saying. So that's that's the formula that's in the preparation assignment, right?
Yeah.
That makes sense.
So the square root part of the z-score, is that what you guys are talking about?
Yeah.
So it would just be the square root of 5.
Okay, okay.
So it's like it'll be 8.8 divided by the square root of 5.
Yeah, to be able to figure out what the denominator is.
So that I get 3.935 blah blah.
Yeah, so that number is going to be the denominator, and then the numerator is going to be 160 minus 150.8.
What did you guys get for your square root of 5?
The 8 divided by square root of 5,
Yeah.
I think 3.5. Hold on, let me do it again. 3.57.
Okay. I'm trying to use my phone and I don't know what number to hit for the square root.
Wait.
Yes, I do, but that's what I got. I don't know if
Are
I'm
you,
hitting the right number.
are you saying that you got 3.5 whenever you were doing the square root part?
That's the number that I got when you do the whole bottom, like the whole denominator, like the standard deviation divided by the square root of 5.
Okay, I got 3.9.
Oh.
Oh,
8.8 divided by the square root of 5, right?
Yeah.
Yeah.
Okay, I got 3.935.
Interesting.
I'll show you my calculator and see if you guys know of something that I'm doing wrong. Can you see?
no, I'm using my cell phone, so that's why I asked.
You have 0.8.
I have 8.8.
Oh, 8.8. Sorry. Oh, that's what I was going off.
Oh, that's weird. I got you got 3.935.
Yeah.
That's what I got this time, so I don't know what I did last time to get that number.
Okay. I thought
Yeah,
maybe I was
got
doing
that
something
number.
dumb.
No, you got it right. So what I was doing, I was just doing 8 divided by square root of 5.
Oh, okay.
I forgot.
Okay.
Maybe that's what happened
Okay.
to me last time too.
Yeah, maybe.
So whenever I do the rest of the problem, I get 2.3379.
Yeah.
But my only concern is that I'm not using the whole number, and hopefully that doesn't affect the decimals, because on this, it wants us to round to the next 3 decimal places. So I just wanted to double check with you guys.
That's what I'm getting to.
What did you get again?
I'm getting 2.3379, but I'm not using the whole long number.
Yeah, that's what I'm
Should.
getting.
I think it's close enough, and because that's what I'd get too. So
Okay, I'm
I don't
gonna do
really
it,
know
guys,
how
really
they
quick.
expect you, unless you have like one of those super fancy science or calculators that you can do that with. I don't know how they expect you to keep all of your decimals.
Okay, guys, I just did it with the number as long as my calculator gave it to me. I wrote it down real quick and then double checked. So you guys can see whatever if you want to look for my proof. It's still the same number. It's still 2.3377 though. So for our final answer, we should have 2.8
338.
Yep.
if we're rounding to the 3 decimal places.
Yeah, that's what I have.
Okay. So what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? And this time we're supposed to round our answer to 4 decimal places.
So if we plug that in as our z-score, we get the answer of 0.0097, right?
Yep, that's what I got.
Yeah, that's the same here.
What I got.
Okay. So moving on, it says, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. So question 10 is, what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
So it should be approximately
Sample size is so large, it's approximately normal, right?
Yeah.
Yeah.
Right, I think so, yeah.
So then number 11 says, what is the mean of the distribution of the sample means? All possible samples of size 81 that could be drawn from the parent population. Round your answer to 1 decimal place.
I don't know if I remember how to do this.
Oh.
I'm gonna search.
That's that one formula that we had a hard time with last time, I think.
For some reason, I cannot find that formula.
Scroll down.
Wait a minute, guys. Oh, this is different though. Never mind.
Oh, isn't that formula just the standard deviation divided by the square root of n? Is that the one we need to use?
Yeah, that sounds
Yeah.
right.
Yeah, that's it.
So we
So the
should
0.7 divided by square root of 81, which is 9, right?
yeah.
Yeah.
My cell phone won't flip.
Round it to 1 decimal.
Okay. Well, if we do that formula, I get the answer of 0.077.
So if we round that to the decimal place of 1, that doesn't.
That's what I was just thinking.
That's what I was thinking.
Standard deviation, though, that they already give us. Does it seem?
Right.
What is the mean of the distribution of the sample mean?
I am confused. I think that's the formula that we use, and I have written in my notes from last time, I have mean of distribution of sample mean written, and then I have that formula next to it. So, I don't know.
So it won't.
So just to clarify, so what did you guys use for your specific numbers?
0.7 divided by square root of 81, which is 9. So 0.7 divided by 9.
Okay.
Right.
Okay.
So
I did 0.07 when I typed it in. That still doesn't really help with the 1 decimal place thing though, but is it just 0.7 that we typed in?
what is the mean of the distribution of the mean? So if I remember from last time, I think this got us last time. Since it says what is the mean of the distribution of the sample means, I think it's just the mean. So 0.7.
Oh, I remember us struggling with this last time.
Yeah, like it wasn't even.
Yeah. I think that is in the last chapter. Let me.
Yeah,
Maybe
but-
that's why I have that written in my notes from last quiz too.
So in lesson 6, it says the mean of the sample means is the population mean.
So actually, it wouldn't be 0.7. What is the sample mean?
So it would be
Oh, 3.5.
So you think it would be 3.5?
I think so, yeah.
So is question 12 just 0.7 then?
12, I think. What is the standard deviation of the distribution of the sample means? And then lesson 6, it says the standard deviation of the sample mean is the equation that we used for last question.
So if we round, and we can round it differently, so that works out a lot better.
Yeah, we can round it to 3 decimal places, which makes more sense.
So 0.078.
That's what I'm thinking, yeah.
Okay.
These wordings.
So 13 says, wait, what?
The wordings of these questions.
I know.
The distribution of the sample mean of the whatever mean is so confusing.
So question 13 says, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? And this
So don't
is
we
in
use the
video.
applet for this?
Yes.
So then do we put 3.3 as the Z-score?
I don't remember. I'm going to try to go back in the video and look at the slide.
3.3 as the Z-score will not work because it doesn't give us any room to use on our applet.
Oh.
Right.
Yeah.
I tried it, so.
Would be less than 3.3. Then do we use the formula that we did last time? Value minus mean divided by the standard deviation divided by square root of sample size?
Can't we just use 3.3 and our standard deviation, or 3.3 as our observation to find a Z-score? Like, can't we just do that formula and put it in the applet?
That's what I was thinking.
Let's try it out.
Okay. They're just throwing the 81 in there to confuse us, right?
Or do you have to, I don't know.
Yeah.
I got like negative 2.857.
I did too. And so when we put that in the applet, we just do the left side, right?
Yeah.
So I get 0.3874.
I can't find to unclick on the right side. I can't, for some reason, my applet won't let me unhighlight the right side. I don't know what's going on with it.
Same.
That's interesting.
Really?
I'm just going to
Are
try.
you getting the same thing as me, Miranda?
Um,
I got 0.3874.
yeah, hold on. I had it. Yeah, that's what I'm getting.
Okay.
What did you guys type in as the z-score?
What?
What did you guys type in as the z-score?
I typed in the negative spot 0.286.
Yeah, that's what I did.
So 2.286.
0.286.
0.286. Sorry, I lost that number that I calculated.
You're okay.
So for the z-score, you just typed in 0.286.
Yeah.
Mine is still being super funky, like my applet won't let me highlight certain things.
Oh, interesting.
So did you guys get 0.61?
0.613 is what I got when I entered that in and highlighted just the lower number.
As the z-score, I get negative 2.857 when I type it in though. So what am I doing?
Yeah. Negative 0.286.
5.7.
Oh, I was using 0.07 as the standard.
5.7.
deviation,
So
not
whenever
0.7.
I typed that in the z-score spot, it just automatically changed to 0.286.
Yeah, mine too.
The middle too, because I noticed whenever I shaded the middle, I'm getting 0.61. But if I only shade just the left, that's whenever 0.3874.
I think you shade the middle and the lower end to get everyone who will score below 3.3.
I don't know for sure I don't know if you should shade the middle. It makes sense that you would shade the middle and the left if you were doing 3.3. But it's also confusing because we get a negative z-score, you know.
Whenever I first typed in the z-score as that, it automatically shaded my middle part. I don't know if that
Mine too.
means anything, but it automatically did. So then I had to unshade it. So does that mean I shouldn't?
I don't know, one of us could try it as like just shading everything to the left of negative 0.286. And
Okay.
some of us could try the middle.
So do you and Jake want to do the 0.6 one, and me and Miranda will do the 0.3 one?
Sure.
Okay.
You're fine.
Okay, so the next question is, it's the same question, but instead of less than, it's greater than 3.3.
Right, so for that
You
we'd
guys
shade
do the-
just the right, right?
And we're gonna wind up getting the same scores.
Yeah, that's why I was thinking, since we got a negative z-score, the less than will be the left, and then greater than will be the middle and the right.
That kind of makes sense too.
So if that's the case, then that's whenever we would use the 0.61.
I think so.
So you guys got 0.387 on the other one?
0.3874. Oh, I need to double check.
Oh.
Yeah, 0.387. I need to take off 4 because
That's what I just realized too.
And this one's 3 decimal places too, so we should type in 0.613.
That's what I was thinking.
Okay.
Okay, so last question. Here's a long one. The United States
Yeah, it is.
Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample.
So,
So for this one, are we going to have to do 177.6 minus 185 divided by 26.7 and whatever the square root of 48 is? Is that the formula we use?
yeah, but I was trying to decide which numbers would go first, 177 or 185.
177 is the observed
Ah,
mean of the boat, so it goes first, and then 185.
okay, that makes sense.
So following that equation, I have my answer is negative 1.92.
Yeah, that's what I got.
I can't get my cell phone to cooperate, so it won't flip, so I can get the square. What's the square root of 48?
The square root of 48 is 6.9282.
I was like, I have no idea.
82. Okay, now I can do it.
And then extreme or no extreme.
And you got negative 1.9202.
Negative 1.920.
Yeah.
Is that what you guys are getting as well?
Yeah.
All right.
Yeah. So that's our answer, isn't it? Because that number is the probability, right? Or do
So-
we need to put it into the applet?
I was thinking put it into the applet, and then it says as extreme or more extreme. So I was thinking click the middle and the right, since we got a negative
Right, the
z-score.
left and the right, but not the middle.
I was thinking middle and right.
So you got
If you do,
0.973.
Yeah, that's what I was thinking.
so middle and right, I'm getting 0.9726.
Yeah, and then you have to round it to 3 decimal places.
So it'll be 0.973.
Yeah.
All right. Is that what you guys, we good?
Yeah.
Okay, I'm gonna submit it. Okay, I missed that question. I missed 13, 14, and 15.
Oh, and 15?
Yeah, 13, 14, and 15. Those are the only ones I missed. Those last 3 questions.
The thing that's throwing me off about question 15, I missed it too, is the note that says as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far as away from the mean as ours in the positive direction. It's the not only part,
Right.
but what does that mean?
So I think what we want to highlight is the 2 outside and not the middle. And so I think our answer should have been 0.055.
Okay.
Oh, I get what you're saying. That makes sense because they want to know what's as far away from the mean as possible.
Right.
Okay.
So you're thinking 0.055?
Yeah.
Okay, I'm for 15.
So probably on question 13 and question 14, it's however we're using the applet that's wrong, huh?
Well, so that for 13 and 14, since it says, come back here. The sample size is 81. I was thinking we use the same formula that we used for 15 to find the z-score.
Oh,
Oh, that might have been right. Yeah.
that's probably it.
Okay, let's see if that is right. Yeah, that's how you do it.
So what number did you get?
13, I got 0.005. And then 14, I got 0.995.
So 0.005 and 0.995?
Yeah.
Okay.
Okay.
Hey.
I gotta get going.
Okay.
Hey, thanks for
All right, guys. Well, see you on Tuesday.
Yeah,
Sounds
see you on
good.
Tuesday.
Okay. Bye.
Bye, guys.
Bye.
Bye.